today. So for the next 30 minutes or so, I'll be discussing some of the topics at hand in terms of providing some practical considerations. When you're looking to start your digitalization plan of your analytical data, touching on some principles and practices to keep in mind as you're undergoing this journey. And then, talking a little bit about how ACDLabs, how we can help in terms of the technology that we provide for your digitalization plan. So, but before I move on, I just wanted to take a little bit of time to talk about how analytical data is plays a role in your R&D organization. So for those of you who were at the last webinar, this may seem familiar to you, but this is what we depict as the digital hierarchy of needs, right? Where most organizations ultimately want to get to the pinnacle of this triangle, where they use historical and new data that's acquired for some sort of machine augmented decision support system. But in order to get there, we really need to look at the basic foundations that are the first few layers in here, where you have analytical experiments that drive the R&D lifecycle. You have systems for integrity and security, whether it's databases or other types of security systems that will mitigate risk. You have productivity, so the actual systems and applications that the scientists will use, right? Whether it's acquisition software, processing software, ELNs, etc. And then you may have a system that should be in place that will assemble the analytical data and pull together other types of information to present a digital twin of your experimental studies. And this digital twin is used to further used upstream in terms of machine learning type of decision support framework. So that's ultimately the goal. But in order to figure out what types of systems are required for the lower levels, we really need to think about how the data is being used by the scientists in the lab today. So this is a typical day in the life of the scientists and their interaction with data and systems. So we have scientists in the lab that will design experiments, that will execute these experiments, they will produce samples from these experiments, and then they are subjected to some sort of analysis, and there are results that are created and generated, and these results are used to make further downstream decisions. Scientists will also interact with a number of different systems, whether it's ELNs, LIMS systems, the acquisition software, as well as the expert applications that they will use in order to perform data processing, interpretation, analysis, or creating reports. And these systems will create some sort of identifiers, right? So project IDs, sample IDs, instrument IDs, some sort of metadata as well, along with the actual data. And the data that is produced from these instruments, we have raw data from these analytical systems, process results. For example, if we have CDS systems that have process results within it, or the analysis of these results. So assembling of the separate analytical data files to represent a study. And generally, that's the case for the interactivity for the scientists in the lab. But now we also have to take into consideration the data scientists, right? So a new type of scientist, and they have their own requirements and their own use of data itself. So we have instruments that instrument data that are placed in repositories. The data format that they require is slightly different. They require data to be cleaned and engineered and structured and standardized in order for it to be useful for them. And then they will take this data and they will perform some sort of analytics, whether it's in the ELN data that they pull, or they will use ML or AI algorithms to create statistics and generate results. and the creation of self-learning systems and statistical views. And ultimately, at the end, this information will get sent back to the scientists for the next steps. So for most organizations, this is a very generic and typical framework for their analytical data management system, where a lot of organizations, they will try and move data from the source, whether it's a physical lab or on disk, push that data to the cloud, and you still have end users that are trying to use that data by interacting with additional applications to query and pull that data from the scientist as well as the data scientist. But in most organizations, they believe that having this data, moving it to the cloud, makes it accessible, which really isn't the case, right? Just because it's in the cloud doesn't mean that it's accessible. A lot of the data that gets pulled into the cloud as separate, and it gets stored as separate repositories, right? So you may have several databases or several data locations, depending on the analytical data file type, the vendor, the instrument type. So the end user still has to really use a number of different types of applications in order to access that data if possible, right? And having the disparate siloed data really causes a lot of confusion and inefficiencies in terms of accessing that data. And ultimately, this data ends up as a data dump because it's not organized and it's difficult to find, even though that the data is in the cloud. And certainly, there are a number of challenges to make this more efficient as you create an analytical data management system. Right? And some of these challenges are pretty obvious. We have heterogeneous data file types. Every vendor will have their own proprietary data format. They'll have their own systems. There are initiatives in place that are trying to standardize the analytical data formats, but they haven't yet gotten to that point where the specifications have been ratified, so it's not fully adopted at all by the vendors. Right? With the heterogeneous data file types, we have inconsistent data ontologies. Right? So they will have their own terminology. They may have their own terminology, but describes the same type of entry within the data file. So this causes significant concern as you try to normalize and standardize metadata within your systems. We also have an issue about scalability and support. So you may already have an analytical data management system in place or something similar, but in order to support additional data workflows, it's often cumbersome or difficult. You may own your data and own the actual system itself, but you have very little visibility in terms of how the system actually works. We also have the issue of the data source variation. So the data sources themselves can be a variety of types, such as CDS systems, where the data itself is stored as a database, right? As a relational database. So you're pulling parts of data together in order to extract out or visualize a complete data file. Or they could be a discrete data file that gets created that can be pulled, or it could be behind some other additional security measures. So it makes it difficult for the data to be pulled and into a central repository. Right. So these are some of the challenges, but again, these challenges are not so large that they can't be overcome. And I'll touch on how we can overcome these challenges a little later on within the talk. But before we get to addressing some of these challenges, I wanted to touch on some of the guiding principles and best practices to keep in mind, especially as you're undergoing or planning your digitalization plan. So FAIR principles. So this is an initiative that is trying to make data far more accessible. And I won't go into too much detail about the FAIR principles, but essentially the idea is that the analytical data within the system should be findable, accessible, interoperable, and reusable. So what does that mean? It means that the data itself should have sufficient metadata identifiers so that the data is searchable. So it's enough description of that data. Data itself is retrievable. So again, is it retrievable via standard protocols? Is the data human and machine readable? Interoperable in the sense that, does it use formal and standardized language for metadata representation? And reusable. Data should have accurate and relevant attributes with data associated with the provenance. So again, there are far more authoritative sources for FAIR and that you can find, but I just want to keep this in mind for you as we move on to planning for your digitalization plan. Another aspect to keep in mind is we talk a lot about democratization of data, and many organizations and many people feel that the idea that the data is in a central location means that it is available to all, which doesn't necessarily translate to it. Right? It doesn't mean that the data is available, because democratization of data really should mean that there are systems and applications in place so that the scientists are enabled to use the data and have access to the data more efficiently. So that means that the data or the system should have effective data marshaling capabilities that will take the data from the source to the destination and every step in between. Systems should have applications in place where they can assemble and organize that data. Right? So you can assemble various data file sources or data files to provide some sort of contextualization. Right? And going back to that idea of combining data files together in order to represent a digital twin of your experimental study. You also have to provide a visual interface for the scientists. Right? So it really has to be accessible to the scientists and what they do with that data, whether they want to review and interact with that data. What level of interactivity do they need? Do they need to just view the data? Most likely not. They want more interactivity with it. They want to interrogate it. They want to process it. They want to possibly reprocess the data. And having one interface to reprocess or process across a number of analytical techniques is something that they would want. And then we have to address the other scientists, the data scientists now, right? For them, they have different requirements for the data. They need the data to be accessible in the sense that it can be abstracted and formatted for machine learning and machine consumption downstream. So for other data science applications. So this is what democratization of data really should be defined as. So now that we've had some introduction, now we can discuss a plan for digitalizing your analytical data. So these are some general steps to take into consideration, and I'll go into a bit more detail of each part. But first, you want to choose one or two data flows of high business value to you, and then I'll touch on how to determine that. You want to map out your processes in the sense that you need to know what is the data that you want to use. So is it what type of data format, what type of instruments, who is actually going to be accessing this data? Is it going to be the analytical scientist? Is it going to be the chemist? Is it going to be the data scientists that want this data? When do they want this data? So the time interval in terms of when the data is acquired to when the data is viewed and required to be processed, that's something that isn't taken into consideration quite often. So, but you do need to take that into account, right? Do they need the data 30 seconds after data acquisition? Do they need the data 30 minutes? Do they need the data the day after, right? So taking to that account. And how do they want that data to be presented? Do they need an interface that allows them to process and interrogate that data? Or do they need access to the process results so that they can abstract that data. Evaluate your systems and infrastructure, right? What are the systems in place? What are the instruments, software? What are your other systems in terms of ELNs and other systems that you need to integrate to? You need to build your team, right? So you need to build who is going to be involved in this plan, right? And then documenting your requirements, right? The actual business process in order to describe your data flow. So choosing the data flow. So I would recommend not trying to what we call boil the ocean, right? Start with one location or one site and look across your data flows to see, you may have several data flows or workflows that you may want to address, but look for some commonalities between them. You may choose maybe one or two amongst the many that are common, and then you may choose those ones to move forward with. If you want to support the other ones that are very closely similar to that workflow, then it's easier to scale up because you have some common elements that are already now been established. Assess the amount of data that's generated for a workflow. And this goes on to the next point, because if you have a data flow that creates a significant amount of data, then this is a good candidate for some sort of automation. Right? Determine which data flow is manually intensive. Do you require the data to be transferred from one location to another? Do you need some sort of data processing and interpretation? Do you need to have some contextualization? Does it need to be integrated with other types of information from ELNs that you are doing now manually? Is there a manual step in terms of reviewing that data before it moves on? So figure out which ones are manually intensive. And based on that, you can account for steps that can be or should be automated or good candidates for automation. Process mapping. So again, data accessibility and interactivity. Always think about the end user. Think about the voice of the data consumer, right? Whoever they may be. So who needs access? Scientists, data scientists, team leads, or other. They may be accessing the same analytical data, but they may use it in a different use case, right? What are the formats that they require? Again, the scientists will want to see the actual data file. They want to see chromatograms and spectra. They want to see results. Data scientists, they want to see the abstracted results of that data processing, where there may be team leads, they require a static view of a report that represents the analytical data. So think about the data and interactivity needs, right? Whether it's data processing, they want to interrogate that data further. Data flow. So again, think about the systems that are going to be touching all of the analytical data that is going to be touching all the systems. So whether it is the acquisition software, the database, the LIMS systems, ELNs. So think about what are the systems that are going to be required for integration, and think about the endpoints for that data. Where is that data destination, right? And the idea of who needs access, that is going to be a key driving force in terms of how you make a plan for your digitalization efforts, because that will often dictate what types of systems are going to be required. Evaluating systems. Again, evaluate current systems, current users, potential users in the future, types of instruments, the vendor, the data formats, the acquisition software, how many sites are going to be required. But in this case, elaborate and talk about what your IT landscape is going to be like. So are there any current initiatives in place that the IT department is undergoing? Have they standardized on a cloud provider or an object store? So you need to understand what their transition is in terms of new technology, so that you can, there are some commonalities, so that it's easier for whatever plan that you devise and whatever systems that you implement to be deployed within your IT landscape, but also further downstream in terms of future-proofing, right? So you want to keep the IT landscape in mind. And then building out your team. So you have your internal team, you have scientists, data scientists, team leads, IT members, but always keep in mind, the data consumers. The voice of the consumer is going to be key, and that's going to be a driving force in terms of how the system is going to be designed, because they are going to be the ones who are providing the requirements for the data interactivity. And obviously, you have your vendor team, you have your account managers, project managers, and professional services that will configure and deploy a solution when it's ready. And define your requirements. So obviously, you need to have a business process map that will describe your entire data flow. So included in this should be user stories. How is the end user actually interacting with the data? What are they doing with it? What are the systems that they're interacting with? That will describe the system functions. But also keep in mind, when you're defining your requirements, the minimum performance that the system should provide. And these have to be realistic. If you have, let's say, a 2 gig high-res LCMS data file that's located on disk on a workstation, and you can't expect that data file to be transferred to the cloud within 30 seconds, including processing and having that data be available. So keep in mind realistic system performance requirements. Built into your requirements, you should have some sort of testing plan in place, right? So define a testing strategy for user acceptance testing. And in that, build into it feedback and fix cycle, right? So once the system is ready and gets deployed into the development arena, before it transitions to production, there has to be some sort of feedback and fix cycle. So this is just an example, a very basic, very generic example of technology assessment and mapping. So you have workflow A and B, where you have data sources, a variety of systems, whether it's waters, thermal, or a PerkinElmer ELN. If there's a vendor, you want to make sure what the vendor actually supports in terms of the systems and data file formats. You have, if there's additional development timelines that are required, keep that in mind, and also any third-party integrations that are going to be required as well. When you move on to looking for or designing your analytical data management system, so these are some of the components that are going to be critical in terms of how they play a role within the system. So there should be some sort of data marshaling system in place, right? Being able to detect a new data file, being able to transfer that data file from source to destination and every point in between. Right? Access interfaces. Again, this is going to be driven by what are the levels of interactivity that the end users require. Does the system require analysis and interpretation of that analytical data? Does it need to have processing involved? As well as the idea of being able to report the analytical results, right? Post-processing. So you need to have standardized reporting. Is the system capable of creating such a report? And the data, once it's processed and reports generated, you want that data to be stored and managed within a database. And that central database should be accessible to everyone, and in the sense that the data itself that's stored in the database should be standardized so you can use it further downstream in the case of data abstraction for machine learning. Right? You want the systems integrations to keep in mind that there are going to be systems that will have to play nicely with each other. No vendor will have all systems across the board that will do everything for you. So whatever system that you go with or the system that you have in place, it has to fit within your data and IT ecosystem. Right? And as I mentioned, the system should have the ability to provide access to the data within that platform. Right? So the data show that data can be abstracted there are different mechanisms such as APIs that will allow data access for the data scientists. So this is a very generic view of an analytical data management system. Right? So you have your data sources at the top. You have your integration layer, so all your systems and subsystems that will play a role. You have your application layer in terms of how the end user will actually interact with that data, and then the database, where the data is stored, whether it's an object store or some other databasing system. Right. So at ACDLabs, we do have technology and systems to account for a number of the challenges that organizations face while you're transforming your analytical data management system or creating it. So for the last 25 years or so, for those of you who are unaware, we work with a number of our vendors to support and import raw data, right, or process data across a number of different instruments and instrument types. So we are able to pull in the raw data and pull it into the Spectrus platform. Right? So we support a wide range of hyphenated chromatography techniques, spectroscopic methods, along with any curve-related data. So for a complete list of data support, you can just head on over to our website to see the types of data formats that we support, but we do support over 150 data file formats. So we can consume your raw data off of your water systems or your broker systems or your SciEx instruments and pull that and standardize it within the Spectrus platform. While we can import and view analytical data within our applications, the data itself are fully interactive. So it's not just an image that we are taking of that raw data, but you can actually process that data, reprocess that data, save it, report it. So it's a fully interactive applications that we support. The data itself is also fully scientifically searchable in the sense that you can database those results and you can search by metadata, chemical structures, reactions, you can perform spectral searches. So this data is fully accessible to the end user. And it is also instantly reusable. Once in our database, you can perform, as I mentioned, queries. You can perform reprocessing of that data itself. So again, the analytical data is very close for the end user. You don't have to go across a number of different applications to query a specific data file. All your data is now standardized within our environment. So this is the technology that some of the technology that we provide in order to support your analytical data management goals. So at the top, again, we have our data sources across a number of different instrument types and vendors. The integration layer, we have a number of different services, automation services. We have a data converting service that allows you to import raw data, translate that, and pull it into a standardized form within the Spectrus platform. We have a processing service that's also available for data processing across techniques. We have application layer that allows for the end user to really interact with that analytical data. So again, whether it's analytical data handling, or we have specific applications such as Catalyst that allows for high throughput experimentation, Luminata, which is our project decision support system. But we also have web components that can be integrated into other applications that you may have in-house, as well as the data itself being able to be accessed by third-party software and systems. The analytical data that's been processed and all the metadata associated with it is housed within Spectrus DB Enterprise Server, but we also interact with a number of different cloud object providers, whether it's Amazon, Google Cloud, or Azure. So for the next few slides, I wanted to touch on some of the application layers and how the data actually looks for the end user. So this is a screen capture of our processing interface. And here, this is a data set, an LCMS data file that has been pulled into our processing environment, some processed, peak detection, integration. We've added a chemical structure within our chemical structure viewing tool, and we've described the components within this LCMS data set. So in this case, we have this crude product, which we don't have an identity for, but we wanted to track this particular crude product. What we can do is database those results. And as you collect more analytical information about this particular component, you can add that to the actual database record itself. So this is an assembled component data set that has NMR data, proton, carbon, and 2D that can be housed together with a complex LCMS data set to give you a full digital characterization of this particular crude product. And as you perform structure elucidation, for example, you can add in chemical structures and additional analytical data to this particular database record. And the database record is fully interactive. So again, if you wanted to reprocess this data because you wanted to reintegrate the LCMS or perform peak picking on your carbon NMR, all you would have to do is simply double click on the chromatogram or spectrum, and it will pull that analytical data back into the processing interface where you can perform reprocessing. And then that data can then be updated back to that same database record. And all your historical operations are accounted for in the audit trail. We are also moving towards the web, and this is a web counterpart of our Windows client that allows you to query metadata, but also perform structure searching as well. So again, it has all the same information, but just in web form for data viewing only. We also have other applications available if you require some more contextualization to your analytical data. In this case, we have an example of Luminata that allows you to create process maps for your synthetic route. You can create different stages, and you can attach different analytical data at each stage of your synthetic route. So you can have, there's a project navigator, process map, there's reference data that you can compare it against the gold standard, batch results, and batch data that can all be tracked, and this project can be created within Luminata. There are other studies, supporting studies that can be created, such as force degradation studies or stability studies for your particular API that can all be assembled within the Luminata interface. We also, again, have a web counterpart that allows you to view the queried results. Again, very similar information where you have process maps, reference data, batch results, batch data, and the project navigator. As we transition to web applications, we still have a very rich Windows-based data processing application, but we are transitioning to the web for data processing as well. So what you see here is a screen capture of Spectrus.js, the first edition that allows for data processing of NMR data, so 1D and 2D data that can be processed directly on the web. Right? We are currently expanding the different techniques that are supported within Spectrus.js, and we are currently developing tools for processing LCMS data. So this is under development at the moment. But aside from actual data interactivity, right, from the end user, we also wanted to provide an interface for you to track and create your own data flows within your environment. So this is what we call Spectrus Conduit that we are developing that allows you to design and build your own analytical data flows. You can specify data sources. You'll be able to convert and standardize the raw data into our environment, set processing routines, and set the destination of that processed results into a specific record set within Spectrus DB. You can automate report creation based on specific data flows or workflows or the type of analytical data that you're handling. as well as engineer that data for third-party applications. So you can extract the process results, engineer it, and format it into a specific format of choice. We also will support custom operations. So again, for those more complex data flows where the current capabilities may not be enough, you have the ability to create custom operations to bridge the gaps. We also are building within Spectra's Conduit the ability to monitor each of your data flow systems, so you can keep track of whether or not that data flow is online, offline, how often they're online or offline, and the number of data files that are created and acquired. Aside from the actual graphical interface, we also have a very rich API for both processing service as well as the database. So your data isn't locked within our environment. You always have access to your data. So you can use the API for abstraction of that data into JSON or XML or CSV for further use downstream when you are using it for BI or ML applications. So for the last 30 or 35 minutes or so, I've described some plans of action for you in terms of what things to take into consideration as you're going along this digitalization journey. But always keep in mind who the users are, who are the data consumers. Choose a general or basic data flow with the highest impact, and also map out the data process, right, or data flow process. And for those of you who are not yet undergoing digitalization, there's no need to wait. You want to leverage the data that you have, the historical data that you've acquired already, and when you're ready, ACDLabs can assist with your data transition.